So today we are starting section 6.3. Our objective is to divide polynomials using synthetic division. There is another way to divide polynomials using long division, similar to what you would have learned in grade school when you had to start dividing multi-digit numbers. I'm not sure that we will actually do it by long division. We'll probably stick to synthetic. I'll have to check. Okay, synthetic is like a shortcut, and it also has other useful applications that we'll talk about today. All right, so our notes for today, just one slide of notes to fill in. One way to divide polynomials that will always work is by using synthetic division. This process allows you to use the coefficients and omit or leave out, take off the variables until the end. Just remember, the divisor is the opposite of what is actually given, and the dividend must be in standard form. That'll make more sense, as usual, when we actually work out an example. Let's work on our first example. Is that one already printed for you?
Yes.
Okay, good.
You.
All right, so these problems generally are not very challenging. The hard or weird part about them is getting them set up, because this is different from what we've done before. So one thing that those notes said was that the dividend had to be in standard form. That's this first polynomial here. Is that in standard form? Yes, our exponents are in decreasing order, so we're all good there. So the setup for this problem, what it looks like, is we have this little box out here, and then we kind of leave a little space, and we've got a long bar here. This is our setup. So our divisor goes in this little box, and in those notes it said it was the opposite of what was written. That's over here. So what we're going to be dividing by is, instead of a positive 1, we put a negative 1 up there. Remember how when we were to solve that for x, we'd set it equal to 0, and we would end up getting x equals negative 1? That's kind of why we use the opposite sign from what's written. Okay, so a negative 1 here. The coefficients are going to get listed along outside of that little box in order. Okay, so what's the coefficient on our first term? 3. Next term, negative 4. If it's a minus 4, we got to treat it like a negative. Next one, 2, and finally, negative 1. We got to list them all out in order. Okay. This is going to seem strange if it doesn't already. Here's the process. The first coefficient that you wrote drops straight down. So we write a 3 right down below that line. We take the number that's in the box and multiply it by that number below. So negative 1 times 3 gives me negative 3. That gets written below the next number. So then we go there. The next thing we're going to do is combine down this column to get our next number to go below the bar. If we combine negative 4 and negative 3, what do we get? Negative 7. And this process continues. Now we're multiplying the negative 1 to the negative 7. What do we get? A positive 7. Where do you think we're going to write it? Under the 2. What do you think happens now? You add them together. What do we get? A 9. And now we multiply by negative 1. What do we get? We get a negative 9. The negative 9 gets written below the negative 1. And we end up with a negative 10. Questions about that? So what this means for our answer for this is going to be written a little strange. So we start back, we were just focusing on this bottom line here, those numbers down there. Those become our new coefficients. We are going to focus on these numbers below the line here. So these become our coefficients. So our new coefficients are going to be 3, -7, +9. I'll explain what the -10 is for in a minute. Our variables drop one exponent from what they were in the beginning. So instead of starting with an x cubed, we're going to start with x squared and then decrease from there. So then just x and then a +9. Kind of like when you did long division back in, third grade, whenever you did that. When you had something left over, what did you usually call it? A remainder. So here our remainder is -10. That would be our answer. So the reason why it's a little bit challenging to check this from what we know right now is that when we get a remainder, we can't then multiply this back to what we had easily to check ourselves. If we were to have a remainder of 0, you could double distribute this divisor into your quotient and see if you get what you started with, the dividend. So our second problem is x cubed plus 4x squared plus x minus 6 is divided by x plus 1. Okay, remember our setup for this. So we've got this little box. Got a bar going through there. What number is going in my little box? -1. A -1 again. We use the opposite of the number back here. Then we need to list out our coefficients. Before we do that, we should check to make sure we're in standard form. Are we? Yes. Okay, so if we're in standard form, we start listing them out. All right, what numbers are going to get listed across the top here? 1, 4, 1, -6. So those come from the coefficients and then the constant here. Remember, if we're subtracting, we treat it like a negative. Shorten that up a little bit. Okay. So for this process, the first number gets dropped straight below the bar. Any numbers below the bar get multiplied by the number in the box. So 1 times -1 is? -1. Where are we going to put it? Under the 4. Okay, so then we combine positive 4 and -1. What do we get? A +3. We're going to multiply that 3 by? What do we get? It goes under the 1 next door. We combine to get -2. We multiply to get +2. We combine to get -4. After we get all those numbers, we actually write our answer. So these become our coefficients, and then the last number becomes our remainder. And we start with a variable that has an exponent 1 degree less than the original problem. So our coefficients are 1, +3, -2. What's going next to my 1? X squared next to the 3, x, and then the -2 does not have an x, it's just a constant now. And our remainder is, okay, so if you want to put our -4, that's fine, just make sure you leave a little space there so I know that that's what your remainder is. So we've got it set up. We used our coefficients across the top here. We use a +3 in our little box. Okay, because we had x minus 3. We start off by dropping our first number straight down. You can kind of think about it as like adding a 0, right? Comes straight down. All right, we take 3 times 5, we get
15.
We add that to negative 6.
9.
We multiply that by 3.
27.
We add that to 4.
31.
We multiply that by 3.
93.
And we add that to negative 1.
92.
Oh, it does come out with a remainder of 92. All right, so let's write our answer back as a polynomial. Can anyone tell me what it should be?
5x squared plus 9x plus 31.
5x squared plus 9x plus 31 with a remainder of 92. All right, number 4 is different. Who can tell me why number 4 looks different? It's not enough numbers. Okay, well, it's not as many numbers as we're used to, right? We're used to it being full of everything in standard form. Is this considered standard form?
Yes.
Yes, it is considered standard form. It's got the highest variable exponent first. It's got the highest exponent first, and then it goes down from there. The difference is that we've only got 2 terms. It's just a binomial. What has to happen for this to work with synthetic division is that we can't leave any of the terms out, meaning that we need an x squared and an x if we start with an x cubed. We've got to have everything filled in all the way down. So if I wanted to rewrite this with an x squared and with an x, what do you think the coefficients on those would have to be?
1.
Not 1. 0. They would have to have coefficients of 0 on them if this is going to not change the problem. Normally, we wouldn't write things that have a coefficient of 0, right? Can we see how x cubed plus 27 is the same as x cubed plus 0x squared plus 0x plus 27? Those are the same. I didn't change the problem. We're still dividing it by the x plus 3. Now, you do not necessarily need to write this polynomial out every time this situation happens, but when you go to set up your synthetic division, you have to put those 0 placeholders in. Okay, so if your degree of your polynomial is 3, it's cubic, you should have 4 numbers across the top there. What number's going in my little box?
-3. Oh,
Yep, you're right. All right, the 1 goes where?
down.
Straight down. We take 1 and we multiply it by. We add that to 0. What's 0 minus 3? Negative 3. We multiply that by negative 3. We get a positive 9. We add that to 0. It's 9. Multiply by negative 3. Negative 27.
0.
We get a remainder of 0. So that means that x plus 3 divides evenly into x cubed plus 27. All right, we still need to write our actual answer. Who can help me out with writing that? Emily?
1x cubed minus 3x plus 9. Sorry, no 9. I wrote that wrong.
Good.
And then remainder of 0.
We have a remainder of 0. So you don't have to put R0. You can. It's okay if you do. But that polynomial is our answer. So what that means is that if we were to take x plus 3 times x squared minus 3x plus 9, and we wanted to multiply those back together, it should equal our starting dividend, x cubed plus 27. Now, I'm not going to make you check those today, okay? But if you wanted to check that problem with the remainder of 0, that's how you would do it. You'd multiply those back together. So related to this topic is the remainder theorem. If a polynomial, what they're calling it p of x, a polynomial of degree n greater than 1, so meaning it's at least a quadratic, is divided by x minus a, where a is a constant, then the remainder is p of a. Now, in words, that sounds a little weird. But what it's saying is that if we do synthetic division and we get a remainder, the remainder is the same thing as if you were to plug that number that you put in your little box in for x, you would get the same number. Okay, so in words, it's a little strange. I'll show you what they mean with an example. All right, so example 5 says use synthetic division to find p of negative 4 for the polynomial x to the 4th minus 5x squared plus 4x plus 12. So I'm going to just go ahead and take away number 6 for right now because that is not enough room for me to do this, so that we can focus on 5. So back in Algebra 1 or earlier this year in Algebra 2, if we were asked to find p of negative 4, we would plug negative 4 into x and we would calculate it all out, right? That's our old school way of doing it. Does that make sense? Do we remember doing that?
Yes.
Okay, I hope so. So the new way is to use synthetic division, and whatever our remainder is the answer. Okay, so we use synthetic division.
What's the name?
Negative 4 is that number that's going in our little box. Okay, p of negative 4 goes in the little box. Is that polynomial in standard form?
Yes.
It sure is, but are we going to need a 0 placeholder?
Yeah. 3.
Yes, for the x cubed term. Notice we go from the 4th to the 2nd. So in between those, we're going to need a 0 placeholder. So what's my first coefficient?
X. 1.
1. Then our 0 placeholder. Then what?
5.
Negative 5. Then,
4.
and then, okay. Questions about our setup? All right, so we go back to that same process. The 1 drops down. 1 times negative 4. Negative 4. 0 minus 4. Still negative 4. Negative 4 times negative 4
4. 16.
is a positive 16. Okay, negative 5 plus 16 is 11. Multiplied by negative 4
44.
is negative 44. Add that to a positive 4. We get negative 40. Multiply that by negative 4. We get 160. And then add that to 12. We get 172. So what that means is that p evaluated at negative 4 is equal to 172, that remainder. So in this case, we don't really care about all those other coefficients. We're not setting up that polynomial unless they ask us to divide a polynomial by another binomial. Okay, if all they're asking us to do is evaluate the function or the polynomial at a certain number, all we really care about is that remainder. So here is our final answer. That's it, 172. Now on this type of problem, if you really wanted to check yourself, what could you do?
Plug it in.
Plug it in. You could actually plug negative 4 into those x's and see if you end up with 172 at the end. If you don't, then either something went wrong in your synthetic division, or something went wrong when you plugged in -4 for x. Those two ways of solving the problem should get you the same answer. So for number 6, we can start setting it up together. What's going in my little box? The -1. Is my polynomial in standard form? Yes. Am I going to need any 0 placeholders?
Oh, yes.
Yes. Where at?
X.
The plain x, the linear term back here at the end. So between the -5 and the -60, we would need a 0 placeholder. Make sure you're remembering to look for those. These problems can go by pretty quick, but if you start going too fast and you forget about that, it will mess you up. All right, that 2 is going to drop down. 2 times -1. -2 added to 6. 4 times -1. Add that to -5. -9. -9 times -1. +9 added to 0. Still 9 times -1. -9 added to -60 is -69. Very good. So those of you that offered an answer got it right. So we could write our answer. P of -1 is equal to -69. Again, if you want to check it, you could actually plug -1 into x here, here. Calculate it all out and see if you got the correct answer. All right. Example 7, parts A and B, ask us to use synthetic division and the given factor to completely factor the given polynomial. So this goes back to what we were doing at the beginning of the lesson, where we had to write out our answer with the decreasing degrees, the decreasing exponents on our new coefficients. And then we're going to see if we can factor that polynomial also. Okay, so we'll do it one step at a time. I'm going to take away part B for right now so we can do part A. So imagine these things are all in parentheses, and it's going to look a whole lot like the beginning did, right? So what number is going in my little box? A -2. Is my polynomial in standard form? Yes, it is. Do I need any 0 placeholders? Not this time. We've got cubed, squared, linear, constant. They're all there. What are my coefficients? 1, -5, and 6. Great. 1, -2, -5, and 6. We put our bar, a little space. The 1 drops down. 1 times -2. It's -2. Add that to another -2. We get -4 multiplied by -2. +8. Add that to a -5. We get a +3 multiplied by a -2. -6. Add those, we get 0, a remainder of 0. That needs to happen if we're going to be able to factor it more. Okay, so if you have a problem like this, worded this way, and you don't get a remainder of 0, something went wrong. Okay, so just keep that in mind. So then we are going to use these as our new coefficients. What's our new polynomial?
1x squared
Mm-hmm.
minus 4x
Plus 3 with the remainder of 0.
Okay, with a remainder of 0. So we're not going to write the remainder of 0. We're just going to take this polynomial. Okay, so this new polynomial that we just found can be factored. How cool is that? We can factor this into 2 binomials, just like we did last semester, last week, a couple days ago. What's going in the front of both of my binomials?
x.
X and X. Both signs have to be the same, and they are both going to be minus. 1 and 3. We needed those numbers to multiply to 3, add up to -4. So for our whole answer, this is one of the factors, x plus 2. They gave us one of the factors. So if we're factoring it completely, x plus 2 is part of our answer. They gave us part of the answer in the beginning to help us get started. And then we found the other two factors. Okay, we're going to stop our notes here today. So I would recommend trying problem 7b on your own. And hopefully we can talk about that tomorrow. But we'll stop the notes here.